So we solved the scaling problem with Amazon EC2 auto scaling. But now we've got a bit of a traffic problem, don't we? Let's take a look at the situation. When customers come into the coffee shop, right now they have three options for which cashier to talk to place an order. And oddly enough, most of them are lining up in one line, causing an uneven distribution of customers per line, even though we have other cashiers waiting to take orders, standing around doing nothing. Customers come in and aren't sure exactly where to route their order. It would help a lot if we added a host to the situation. A host stands at the door, and when customers come into the coffee shop, they tell them which line to proceed to for placing their order. The host keeps an eye on the cashiers taking orders and counts the number of people in line each cashier is serving. Then it will direct new customers to the cashier that has the shortest line, is the least bogged down, thus allowing the lines to be even across cashiers and helping customers be served in the most efficient manner possible. The same idea applies to your AWS environment. When you have multiple EC2 instances, all running the same program to serve the same purpose, and a request comes in, how does that request know which EC2 instance to go to? How can you ensure there's an even distribution of workload across EC2 instances? So not just one is backed up while the others are idle, sitting by. You need a way to route requests to instances to process that request. What you need to solve this is called load balancing. A load balancer is an application that takes in requests and routes them to the instances to be processed. Now, there are many off-the-shelf load balancers that work great on AWS. And if you have a favorite flavor that already does exactly what you want, then feel free to keep using it. In which case, it will be up to your operations team to install, manage, update, scale, handle failover and availability. It's doable. Odds are what you really need is just to properly distribute traffic in a high performance, cost efficient, highly available, automatically scalable system that you can just set and forget. Introducing Elastic Load Balancing. Elastic Load Balancing, or ELB, is one of the first major managed services we're going to talk about in this course. And it's engineered to address the undifferentiated heavy lifting of load balancing. To illustrate this point, I need to zoom out a bit here. To begin with, elastic load balancing is a regional construct. Now we'll explain more of what that means in later videos, but the key value for you is that because it runs at the region level, rather than on individual EC2 instances, the service is automatically highly available with no additional effort on your part. ELB is automatically scalable. As your traffic grows, ELB is designed to handle the additional throughput with no change to the hourly cost. When your EC2 fleet auto scales out, as each instance comes online, the auto scaling service just lets the elastic load balancing service know that it's ready to handle the traffic, and off it goes. Once the fleet scales in, ELB first stops all new traffic and waits for the existing requests to complete, to drain out. Once they do that, then the auto scaling engine can terminate the instances without disruption to existing customers. ELB is not only used for external traffic. Let's look at the ordering tier and how it communicates with the production tier. Right now, each front-end instance is aware of each back-end instance. And if a new back-end instance comes online in this current architecture, it would have to tell every front-end instance that it can now accept traffic. This is complicated enough with just half a dozen instances. Now imagine you have potentially hundreds of instances on both tiers, each tier shifting constantly based on demand. Just keeping them network efficiently is impossible. Well, we solve the back-end traffic chaos with an ELB as well. Because ELB is regional, it's a single URL that each front-end instance uses. Then the ELB directs traffic to the back-end that has the least outstanding requests. Now, if the back-end scales, once the new instance is ready, It just tells the ELB that it can take traffic and it gets to work. The front end doesn't know and doesn't care how many back-end instances are running. This is true decoupled architecture. There's even more that the ELB can do that we'll learn about later, but this is good enough for now. The key is choosing the right tool for the right job, which is one of the reasons AWS offers so many different services. For example, back-end communication. There are many ways to handle it, and ELB is just one method. Next, we'll talk about some other services that might work even better for some architectures.
ELB, elastic, ELB, elastic load balancing. ELB, elastic load balancing.
Let's talk about messaging and queuing. In the coffee shop, there are cashiers taking orders from the customers and baristas making the orders. Currently, the cashier takes the order, writes it down with a pen and paper, and delivers this order to the barista. The barista then takes the paper and makes the order. When the next order comes in, the process repeats. This works great as long as both the cashier and the barista are in sync. But what would happen if the cashier took the order and turned to pass it to the barista and the barista was out on break or busy with another order? Well, that cashier is stuck until the barista is ready to take the order. And at a certain point, the order will probably be dropped so the cashier can go serve the next customer. You can see how this is a flawed process, because as soon as either the cashier or barista is out of sync, the process will degrade, causing slowdowns in receiving orders and failures to complete orders at all. A much better process would be to introduce some sort of buffer or queue into the system. Instead of handing the order directly to the barista, the cashier would post the order to some sort of buffer, like an order board. This idea of placing messages into a buffer is called messaging and queuing. Just as our cashier sends orders to the barista, applications send messages to each other to communicate. If applications communicate directly, like our cashier and barista previously, this is called being tightly coupled. A hallmark trait of a tightly coupled architecture is where if a single component fails or changes, it causes issues for other components or even the whole system. For example, if we have application A and it is sending messages directly to application B, if application B has a failure and cannot accept those messages, application A will begin to see errors as well. This is a tightly coupled architecture. A more reliable architecture is loosely coupled. This is an architecture where if one component fails, it is isolated and therefore won't cause cascading failures throughout the whole system. If we coded the app won't, this is an application B has a failure and cannot accept those messages. If we is where if a hallmark trait of a tightly coupled architecture is where a hallmark trait of a
Sorry.
tightly coupled architecture is where if a single component fails or changes, it causes issues for other components or even the whole system. For example, if we have application A and it is sending messages directly to application B, if application B has a failure and cannot accept those messages, application A will begin to see errors as well. This is a tightly coupled architecture. A more reliable architecture is loosely coupled. This is an architecture where if one component fails, it is isolated and therefore won't cause cascading failures throughout the whole system. If we coded the application to use a more loosely coupled architecture, it could look as follows. Just like our cashier and barista, we introduced a buffer between the two. In this case, we introduced a message queue. Messages are sent into the queue by application A and they are processed by application B. If application B fails, application A doesn't experience any disruption. Messages being sent can still be sent to the queue and will remain there until they are eventually processed. This is loosely coupled. This is what we strive to achieve with architectures on AWS. And this brings me to two AWS services that can assist in this regard. Amazon Simple Queue Service, or SQS, and Amazon Simple Notification Service, or SNS. But before I dive into those two services, let me just order a to-go coffee on our cafe website. Done. All right, well, that's great. I should get a message when that order is ready. First up, let's discuss Amazon SQS. SQS allows you to send, store, and receive messages between software components at any volume. This is without losing messages or requiring other services to be available. Think of messages as our coffee orders and the order board as an SQS queue. Messages have the person's name, coffee order, and time they ordered. The data contained within a message is called a payload, and it's protected until delivery. SQS queues are where messages are placed until they are processed, and AWS manages the underlying infrastructure for you to host those queues. These scale automatically, are reliable, and are easy to configure and use. Now, Amazon SNS is similar in that it is used to send out messages to services, but it can also send out notifications to end users. It does this in a different way, called a publish subscribe or pub sub model. This means that you can create something called an SNS topic, which is just a channel for messages to be delivered. You then configure subscribers to that topic and finally publish messages for those subscribers. In practice, that means you can send one message to a topic, which will then fan out to all the subscribers in a single go. These subscribers can also be endpoints, such as SQS queues, AWS Lambda functions, and HTTPS or HTTP webhooks. Additionally, SNS can be used to fan out notifications to end users using mobile push, SMS, and email. Taking this back to our coffee shop, we could send out a notification when a customer's order is ready. This could be a simple SMS to let them know to pick it up, or even a mobile push. Oh, in fact, it looks like my phone just received a message. Looks like my order is ready. See you soon.
Okay. Mhm.
EC2 instances are virtual machines that you can provision with minimal friction to get up and running on AWS. And EC2 is great for all sorts of different use cases, like running basic web servers to running high-performance computing clusters and everything in between. That being said, though EC2 is incredibly flexible, reliable, and scalable, depending on your use case, you might be looking at alternatives for your compute capacity. EC2 requires that you set up and manage your fleet of instances over time. When you're using EC2, you are responsible for patching your instances when new software packages come out, setting up the scaling of those instances, as well as ensuring that you've architected your solutions to be hosted in a highly available manner. This is still not as much management as you would have if you hosted these on premises, but management processes will still need to be in place. You might be wondering, what other services does AWS offer for compute that are more convenient from a management perspective? This is where the term serverless comes in. AWS offers multiple serverless compute options. Serverless means that you cannot actually see or access the underlying infrastructure or instances that are hosting your application.
So,
Instead,
okay.
all AWS offers services does AWS offer for compute that are more convenient from a management perspective. This is where the term serverless comes in. AWS offers multiple serverless compute options. Serverless means that you cannot actually see or access the underlying infrastructure or instances that are hosting your application. Instead, all the management of the underlying environment from a provisioning, scaling, high availability, and maintenance perspective are taken care of for you. All you need to do is focus on your application, and the rest is taken care of. AWS Lambda is one serverless compute option. Lambda is a service that allows you to upload your code into what's called a Lambda function, configure a trigger, and from there, the service waits for the trigger. When the trigger is detected, the code is automatically run in a managed environment, an environment you do not need to worry too much about because it is automatically scalable, highly available, and all of the maintenance of the environment itself is done by AWS. If you have 1 or 1,000 incoming triggers, Lambda will scale your function to meet demand. Lambda is designed to run code under 15 minutes. So this isn't for long-running processes like deep learning. It's more suited for quick processing, like a web backend handling requests, or a backend expense report processing service where each invocation takes less than 15 minutes to complete. If you aren't quite ready for serverless yet, or you need access to the underlying environment but still want efficiency and portability, you should look at AWS container services, like Amazon Elastic Container Service, otherwise known as ECS, or Amazon Elastic Kubernetes Service, otherwise known as EKS. Both of these services are container orchestration tools. But before I get too far here, a container, in this case, is a Docker container. Docker is a widely used platform that uses operating system level virtualization to deliver software in containers. Now, A container is a package for your code, where you package up your application, its dependencies, as well as any configurations that it needs to run. These containers run on top of EC2 instances and run in isolation from each other, similar to how virtual machines work. But in this case, the host is an EC2 instance. When you use Docker containers on AWS, you need processes to start, stop, restart, and monitor containers running across not just one EC2 instance, but a number of them together, which is called a cluster. The process of doing these tasks is called container orchestration, and it turns out it's really hard to do on your own. Orchestration tools were created to help you manage your containers. ECS is designed to help you run your containerized applications at scale, without the hassle of managing your own container orchestration software. EKS does a similar thing, but uses different tooling and with different features. Both Amazon ECS and Amazon EKS can run on top of EC2. But if you don't want to even think about using EC2s to host your containers, because you either don't need access to the underlying OS or you don't want to manage those EC2 instances, you can use a compute platform called AWS Fargate. Fargate is a serverless compute platform for ECS or EKS. That's a bit high level, and it might be confusing, so let's clear that up. If you are trying to host traditional applications and want full access to the underlying operating system like Linux or Windows, you are going to want to use EC2. If you are looking to host short-running functions, service-oriented or event-driven applications, and you don't want to manage the underlying environment at all, look into the serverless AWS Lambda. If you are looking to run Docker container-based workloads on AWS, you first need to choose your orchestration tool. Do you want to use Amazon ECS or Amazon EKS? After you choose your tool, you then need to choose your platform. Do you want to run your containers on EC2 instances that you manage, or in a serverless environment like AWS Fargate that is managed for you? Those are just some of your compute options with AWS, and it's not even a complete list. Check out the notes for more information on AWS compute services, as well as others that we didn't get to talk about in this video. Hey everyone, I hope you've been enjoying the course so far. We're going to do check-ins like this one after each major topic to review what you've learned. First things first, what is cloud computing and what does AWS offer? We define cloud computing as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. This means that you can make requests for IT resources like compute, networking, storage, analytics, or other types of resources, and then they are made available for you on demand. You don't pay for the resource upfront. Instead, you just provision and pay at the end of the month. AWS offers services in many categories that you use together to create your solutions. We've only covered a few services so far. You learned about Amazon EC2. With EC2, you can dynamically spin up and spin down virtual servers called EC2 instances. When you launch an EC2 instance, you choose the instance family. The instance family determines the hardware the instance runs on, and you can have instances that are built for your specific purpose. The categories are general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. You can scale your EC2 instances either vertically by resizing the instance or horizontally by launching new instances and adding them to the pool. You can set up automated horizontal scaling using Amazon EC2 autoscaling. Once you've scaled your EC2 instances out horizontally, you need something to distribute the incoming traffic across those instances. This is where the elastic load balancer comes into play. EC2 instances have different pricing models. There is on demand, which is the most flexible and has no contract. Spot pricing, which allows you to utilize unused capacity at a discounted rate. Savings plans or reserved instances, which allow you to enter into a contract with AWS to get a discounted rate when you commit to a certain level of usage. And savings plans, which apply to AWS Lambda and AWS Fargate, as well as EC2 instances. We also covered messaging services. There is Amazon Simple Queue Service, or SQS. This service allows you to decouple system components. Messages remain in the queue until they are either consumed or deleted. Amazon Simple Notification Service, or SNS, is used for sending messages like emails, text messages, push notifications, or even HTTP requests. Once a message is published, it is sent to all of these subscribers. You also learned that AWS has different types of compute services beyond just virtual servers like EC2.
Serverless.
There are container services like Amazon Elastic Container Service, or ECS. And there's Amazon Elastic Kubernetes Service, or EKS, both of which are container orchestration tools. You can use these tools with EC2 instances, but if you don't want to manage that, you don't need to. You can use AWS Fargate, which allows you to run your containers on top of a serverless compute platform. Then there is AWS Lambda, which allows you to just upload your code and configure it to run based on triggers. And you only get charged for when the code is actually running. No containers, no virtual machines, just code and configuration. Hopefully that sums it up. Catch you in the next one.
Okay, batch processing. So the batch processing meaning group. So basically, batch means group, right? So group of data processing without any manual intervention. So what would be the best, not general purpose, not memory, compute optimized. It has to be compute optimized, not a storage. Yes. What are the contract lengths for Amazon EC2 reserve instances? 1 year, 2 year, 3 years. For reserve instances. 3 to 5 years. Probably 3 to 5 years. That's correct. 1 to 3 years. Spot instances. Six months. Elastic load balancing. Last, yep, that's what I'm talking about. So it is the first one. Elastic load balance, ensuring that no single Amazon EC2 instance has to carry the full. Okay. So let's see this first one. Yes.
I want to talk to you about high availability. Say you want to grab a cup of coffee at the cafe, but today is not just a normal day in our city. Today, there is a parade coming to march down our street in celebration of all of the wonderful cloud migrations that have been successful. This parade is going to march right in front of our shop. This is great because who doesn't love to look at floats and balloons and have someone throw candy at them from the street? But this is also bad because while the parade is coming down the street, our customers who are driving to come get coffee will be diverted and won't be able to stop by the shop. This will drive sales down and also make customers unhappy. Luckily for us, we thought ahead. We thought long ago, what would happen if for some reason our customers couldn't make it into the shop temporarily? Like if there was a parade, or if there's a flood, or some other event that blocks us from getting into the shop. Well, no matter the reason, we need to be highly available for our customers. So I'll let you in on a secret. This isn't our coffee shop's only location. The cafe is actually a chain, and we have locations all around the city. That way, if a parade comes down the street, or if there was a power outage on our block, no worries. Customers can still get their coffee by visiting one of our shops just a few blocks away. We still make money and they get their coffee, all is well. AWS has done a similar thing with how the AWS global infrastructure is set up. It's not good enough to have one giant data center where all of the resources are. If something were to happen to that data center, like a power outage or a natural disaster, everyone's applications would go down all at once. You need high availability and fault tolerance. Turns out it's not even good enough to have two giant data centers. Instead, AWS operates in all sorts of different areas around the world called regions. We're going to talk about this in depth in upcoming videos. In the meantime, I'm going to sit here and relax because I know my business is highly available, regardless of any parades blocking the street.
Okay.